All right, welcome everyone to our Friday Tech Talk. We have a special guest today. It is McKay More. He is a Tech Academy graduate, and he graduated. Did you graduate the C# boot camp, or was it
Yeah,
the software developer?
it was so I did C# and Python. So
Okay,
whichever one is both of those.
yeah, software developer boot camp, which
Okay,
is
nice.
our full stack boot camp with Python and C#. And he currently got a job with Go Engineer right after graduation, and now he's working with Selectel. And today's talk is desirable difficulties. And he's going to talk about a new approach to structured learning. He's going to go over how to maximize your learning power and strategies and techniques to fast track success. Attendees are welcome to ask questions in the chat. We'll have a Q&A towards the end. And I can open up the mics at the end if you want to ask a verbal question.
Perfect.
All right, welcome all. Welcome, McKay, and take it away.
Awesome, thank you. Well, I wanted to thank everyone for coming. I hope this is a good, beneficial sort of lecture for you guys. And I hope that as we go through, that if you pop questions in the chat, we'll be able to get those answered. And yeah, I hope this is beneficial for you guys. Yeah, so let's see. So we'll start with I'm going to start just a little bit with my background, and then we'll go into talking about desirable difficulties and then learning generally. So I first got my degree in psychology. I studied at BYUI, which is a college in southeastern Idaho. And I was intending to go and become a counselor. I realized that with counseling, I would pretty much graduate, start a private practice, and that would be sort of my next, 20 to 40 years or whatever of my career. And I realized that I wanted more like variability in what I did, and was looking for things that had a lot of opportunity. And so I'd always been interested in computer programming. When I was a kid, I had done like the Khan Academy. I don't know if you guys have heard of that, but they have like a little program for like, I guess it's like a sort of a learning series for JavaScript. And so you can write JavaScript in the browser, and then you have a little page that displays it. So I created a little game where you're this little cube guy who collects like other cubes. And then after like 60 seconds or so, your score is like presented to you. And so that was fun. I enjoyed that, but that was probably my first programming or experience with programming. And then, yeah, I'd done this degree in psychology and realized that I wanted to sort of change my career trajectory and change what I'm doing, and decided to go to the software developer bootcamp at the Tech Academy. Originally, I was looking for places that had like an in-person like office. And so I found that they had a office in Salt Lake. And so I moved down to Salt Lake from Rexburg to do this boot camp. But the funny thing is I just ended up doing it entirely online. So moving down to Salt Lake was all for naught. And then I have pursued some other education. But the big things, I did the boot camp, I got hired at a place called Go Engineer, and then I've recently switched jobs to a place called Select Health, where I'm working remotely. So I'm really interested in learning and developing. And so my background in psychology has helped me a lot in understanding how to learn effectively and how to approach your learning. So I guess before we go into like these individual principles, I think it's important to understand why it's important to structure your learning. When you're learning, if you would like to, make the best use of your time, it's important to follow some sort of program, or at least develop the ability to understand what's good and what's not good, so you don't waste your time doing things that aren't super helpful. Additionally, when you learn a topic and master that topic, not only does your perceived ability in that topic grow, but when you master a topic or get really good at it, you have this idea that you are someone who is capable of learning and understanding things and growing. And that's a really powerful thing. once you have that, learning how to learn or perceiving yourself as competent in being able to learn, that's like a really powerful thing. And I'm sure all of you guys know that software engineering is a lot of learning and continuous learning. And so these tools will be really important. And then I guess additionally is that after you learn how to learn and maybe get through some of those fears and anxieties about learning or feeling like you're not smart enough, once you have that core competency, you're empowered to learn whatever you like. Okay. I'm going to give a brief overview of learning contexts and what makes a good learning context. So this would be understanding what environment you want to place yourself in when you are wanting to learn. So there are these like four things that can make an expert. This is pulled from a video from Veritasium. He's an online science educator. So these four things: a valid environment, many repetitions, timely feedback, and deliberate practice. So a valid environment is one in which you can learn something from the environment. So an example of a valid environment is, if I was playing tennis and I was swinging the tennis racket and I scored a point against my opponent, I sort of learned that the steps I took to do that were good, and I could develop my ability in those things. Example of invalid learning environments, or environments where you really don't learn, like if you have someone who's a gambler and has been gambling for 20 years, they have like many experiences of gambling, and they have a lot of feedback about whether they won or lost the thing. But if you're playing, placing bets on the roulette table, it's not the case that continued practice at that thing helps you get better at the roulette table. It's just a game of chance every time, right? And additionally, short-term stock prices. Obviously, if you have like insider information or something like that, you can have an idea. But if you bet on the short term, some people can make money, but a lot of people lose money because it's not a nice, valid learning environment because there's so much random variation in it, or what appears to be random variation. Another important thing for learning, and this is going to come to no surprise to you guys, but many repetitions and deliberate practice on the thing. Okay, if I'd like to get better at something or some ability, it's important that I practice that thing a lot, and I'm very deliberate about wanting to improve on that thing. So no surprises there. And then the last thing that I think is really important is that you get timely feedback for a learning context. So an example of this, so imagine you are practicing tennis, and because tennis is a game and there is an end goal to the game, steps that get you along the path to winning that game are a type of feedback, right? So if I hit the ball and it lands outside of the tennis court, or if I swing and it just goes like a mile high and then I never see the ball again, that's some feedback of oh, what I did there was not beneficial, or it didn't help me get closer to the end state that I'm desiring for this game. And so there is some feedback embedded in the game of tennis, but imagine the difference of feedback if you were just practicing alone versus if you had four experts there coaching you, guiding you, telling you, describing what would be good to do, or critiquing your form. When you have those people that are giving feedback, as well as just the feedback generated from playing a game of tennis, you have a better experience or learn more quickly, or rather are able to learn in this environment. Okay, so the title of this talk has desirable difficulties in the title, so we're going to be talking about it. So I think from my undergraduate degree, I was a TA for a few classes, and as well as I learned this in the classes that I took that talked about learning, but it is often the case that students select learning activities that are easy rather than those that are effective. So I'll give an example here. So an example of one that's easy but not entirely effective is rereading the text or rereading your notes. So when someone rereads a text or rereads the notes, they look over and they feel like they're doing something. but there's no real deep engagement with the material when you're just passively rereading something. And what you're wanting is a deeper level of engagement that more than that which can be given from this, surface level activity. So when I talk about this desirable difficulty, I'm saying that we need to engage in a strenuous action in learning if we want to have good outcomes in learning. So there is also non-desirable difficulties. So if you had to, go uphill both ways to get to your school, that's an example of undesirable difficulty. Or if you have a professor or teacher, or if you read a blog and they are just awful at describing the thing you're trying to learn, that's an example of something that's undesirable, right? So it makes the learning experience much more difficult, but doesn't really give you much of an impact on your ability to learn. So an example of a like difficult or a desirable difficulty would be, say I'm reading my notes, and then before I have all my terms that I'm wanting to go over, and before I look at them, I cover my hand over the definitions and I look at the term and try to recall to my mind the term or the definition for that thing. This is an example of retrieval, where we're trying to retrieve the thing that we've learned. And an awesome thing about retrieval is that if you fail to retrieve the thing, it's a clear indicator that you don't understand the thing. So even if when you looked at the term, oh, yeah, that looks familiar, and sometimes people will associate familiarity for understanding, but if it is just familiar, then it is not a true learning thing. Like, things can be familiar without you actually learning or knowing them. So in this learning context, where do we place desirable difficulties? So how do we engage in the material we learn in a beneficial way, such that it positively affects our outcome? So I'm going to give just 5 ideas within the psychological literature that can help you engage in desirable difficulties when you're learning. So these are generation, elaborative interrogation, retrieval practice, interleaving, and changing learning contexts. Before we go into this one, though, does anyone have any questions or any comments before we head further into the discussion?
Yeah, I don't see anything in chat yet, McKay.
Okay. Yeah, no worries.
Go ahead.
We'll just keep going through. So the first one we're going to be going over is generation. And in the psychological literature, this is often called the generation effect. So the big study, or I guess the first study that I learned about that kind of talked about this idea, is people were trying to memorize like words. And if the individual, so some people were given a list of words and they were told to memorize those. And then some of the people were given like partial words, or I think for this study, they were asked to generate the words, or had they had a word and there were some blank spaces within the word and they had to generate the letters there. Anyways, the idea is that when these people engaged in effort with the learning material in a self-created or in a creative or like a generative way, their learning outcomes improved, right? And so if you generate your learning, or you generate, or as a step to your learning process, you are engaging in some form of generative activity, it's going to be more effective than not. So an example of this is, and I'll try to become, I'm going over a lot of abstract things. So as I go through each of these steps, I'll try to ground it into, okay, like McKay's talking about this thing, how can I apply this thing? And I see one of the big ways that you can apply this idea of the generation effect is, I guess, in interactions with large language models. So say I am writing a program and I'd like to accomplish a particular thing. There is a thing that I sort of know how to do, but I don't quite know how to accomplish it. There are 2 approaches I could take. I could say, okay, I don't know exactly how to do this thing, though I can describe how to do it. So what I'll do is I'll just go to ChatGPT or Gemini or Claude and type in what I'm wanting to have solved. I have their response generated. I copy their response, paste it into my program, and then I run it. It runs, and then I just move on to the next thing. So that is one possible approach. And then additionally, so with that approach, I will have not really trained myself or given myself practice in the area of programming. Like I pretty much just had a question and then was able to arrange it well enough that I was able to get a good response from a large language model, and then I pasted that program. It is very unlikely to be the case that if I try to do something like that again, that I'll magically have the ability to be able to write that thing that I didn't have initially, right? It's almost certainly not going to be the case that if I just copy and paste from Google or Gemini or ChatGPT, that I will, have this ability, this programming ability bestowed on me. If I want to engage in learning and memory for the various concepts in programming, I need to program, right? And so large language models are incredibly helpful in maybe getting, if you have not very much of an idea of how something is to be accomplished, they can help you generate some of that. Additionally, if you know how something is done and it's just a matter of writing it, then large language models can come in handy, because you could just describe what needs to be written, and you typing in a large language model would take a shorter amount of time than you typing it out, right? And additionally, large language models are really good for exploring areas where you don't know, right? Your known unknowns, maybe. So in this case, for the generation effect, if I'm wanting to learn the syntax or learn the what the functions do for a particular programming language, instead of merely just going to the docs straight away, and actually I would do both of these things. Instead of just merely going to the docs, reading through the entire docs, and then starting, what I'd probably do is I'd pose an interest or something I'm wanting to resolve programmatically, and then I would read some of the docs, and then as I'm reading the docs, think about how I could apply it or even work to implement it in a particular program I'm writing. So I'm trying to generate some of, or I'm trying to use or be creative with these concepts that I'm learning in terms of like programming syntax or particular like programming entities. So that creative aspect helps us learn rather than just the dispassionate studying of the material, though both are important, right? And so that is the generation effect. So the next one we'll go over, I enjoy quite a bit. And this is the idea of elaborative interrogation. So within learning contexts, one important thing is to find your blind spots. And the difficulty about blind spots is that when you're searching for these gaps in your knowledge, the very fact that you don't know them is difficult, right? Because I don't know what I don't know, right? Sometimes it's the case that I know those things, but for the most part, when I'm engaging in a something new, something I haven't interacted with before, there are so many things that I don't know, right? So I don't know that I don't understand this particular thing, right? And so the idea of elaborative interrogation helps you pick apart the structure of your understanding and finding the blind spots. So an example of this, or I guess I'll just read this. So it's the process of asking why on a particular idea or thing, and it helps you flesh out your understanding and search for gaps in your knowledge. So an example of this could be like, okay, maybe I am wanting to iterate through for a list in JavaScript, I'm wanting to iterate through every element. And I find that there are two ways to do it. So I can, at least two ways, right? I'll just describe two ways. So there's one thing I can do is I can have the list and then do .for each and then pass in a function that describes what I'd like to happen on each iteration of the loop, right? And then I also have an approach where I can just do a regular for loop, right? So I do, for I int I, or I guess for I equals 0, I is less than the list.count, and then I++. So the initial condition, the exit condition, and then what I would like to occur at the end of each iteration. So I could ask, like, why do I have this thing and why do I have this thing? What is the use between those? And as you ask these questions, it forces you to sort of evaluate and analyze your understanding and sort of chip away and refine what your thinking is on a particular topic. And so if I were to study this for each, and maybe I will just pull up, oh no, I can only see the, actually, you guys can see that, right? So we'll just like hop in the console real quick. Okay, so what I'm describing here is that if I have an array, we'll just do ASDF, and then I will say, okay, I have 1, 2, 3, 4 within this array, and then look, if I do ASDF, then I have this array. So there are two approaches for me to iterate through this array. I can do ASDF.forEach, and then I can pass in a function here that describes what I'd like to do per iteration of the array. And so this would be value. This would be the value, and then maybe I just want to console.log that value. And this may be the index. So if we do that, you see I've iterated through each element in this array, and I've console.log the value for that thing. And so the difference between this and something like doing a regular for loop where I have like, I guess I equals 0, and then I have I is less than ASDF.count, and then I have I++, and then I give my my thing in here. So this is different in that in this for each, I don't have access to this index, right? So I'm creating this index in this for each, and I'm going through until the index reaches this. So in this situation, this obscures it a little bit because I did 1, 2, 3, 4, but the index for these elements within this array are 0, 2, 3, and 4, right? So like I'll show, so ASDF, if I type in 0 here, I'm going to get return 1 because that's the 0th index of the array. So when I use this .for each, I iterate through the value itself, whereas if I were to use that for statement, I'd be interacting with the index. So there are situations where a .for each makes more sense when I don't need access to the index number, or there are situations where, yeah, I'd like to have the index. An example of it would be if I'm iterating through the list, and for every step on this list, and we're going to do some sort of logging, and the number, or I guess the index number is an important thing. So I could say, okay, starting operation number 1 for this variable, right? Starting operation number 2, completed operation number 2. And so if I had logging, it does make sense to do a for. So that's a little bit of an aside. But engaging in this elaborative interrogation and understanding, okay, why are there these two different things? Why are we interacting with these in a particular way? And trying to get to the root or base of your knowledge and sort of exploring and figuring out the limits of, as well as, you know, the facets of your knowledge. And so this is a really powerful thing because it forces you to engage deeply with it, and also gives you, I guess, almost free content for these things. So I could learn .for each, and I could learn the for loop individually. But until I compare and contrast these two, I engage in interrogation of, oh, why do we have these two things? I won't deeply understand what the use is, right? So elaborative interrogation is a cool concept, and I think an interesting idea, and it's a really, really powerful thing. I guess another thing that I do as part of my process for, I don't know, maybe understanding things or my practice of learning is that I will take a particular concept for a thing, I will generate a definition for that thing, and think about how that thing applies to different places. So I will think about, okay, what is this idea of fear, right? What if I were to give a definition to fear? What would it be? Because like we have an idea of what fear is, but we don't have this concrete, like it would take a bit, like it would take, you could describe what is fear and what is not fear, but it would be difficult to just give you a succinct one-liner for what fear is, right? And so that shows like, oh, well, I know how this term is used, and I could use it myself, but I don't quite understand what is meant by the term in its strict definition. Of course, you understand it in context. So this is elaborative interrogation. Okay, so next we have retrieval practice. So I guess we'll go back. So we've talked about generation, elaborate interrogation, and then we have retrieval practice. So what retrieval is, it's the idea of the process of recalling information that you've learned previously. And doing this is important because when the sign that someone has learned a thing is that they can recall and describe that thing. So the sign that I've learned, the difference between a .for each in JavaScript and a for loop, is that I can like describe it and I can show you that thing, right? So if I were to have learned what a .for each loop does previously, and then I would go into a situation like this, and I'd be like, oh, actually, I don't know what it is, right? So that shows that I had lost some learning for a particular thing. And so what retrieval practice is all about is the process of recalling that information learned previously, and by so doing, showing you where you have forgotten things. And additionally, you get the benefit of of retrieval, which is when I retrieve things, I'm more likely to remember them later. So sort of the academic history of this concept of retrieval practice, it doesn't actually connect back to Hermann Ebbinghaus, but Hermann Ebbinghaus did this study where he would memorize nonsense words or nonsense like sounds, maybe nonsense syllables. That's probably the best way to put it. Like cat, or I guess cat's sounds cool one, but you know what I'm saying. But he would memorize these things, and then he would try to test himself to see how well he did in being able to retrieve these things. Okay, so you have this like graduate student who is like memorizing these long lists of things and then testing himself on his knowledge of them. And he found that when he initially learned something, he had this understanding or was able to recall the list. And then, and this is the graph up in the top right, but he had this initial memory on this particular thing. And then as he continued, he forgot the thing like relatively quickly. So if you see, I don't know exactly if this graph is correct, but it's more about illustrating an idea. Like, oh, okay, we have first learned, we have 100%. And then just in 1 day time, I have 80%, right? And so you can see that I would forget quickly. And if this trend continues as represented by this gray line down here, at 3 days, I would remember 60% of what I learned. I don't know about you, but that's like incredibly bleak to think that, you know, I learned this particular thing, and then so shortly after I've learned it, I just could not even tell you about it. And so what retrieval practice does is it helps you get back to that state of understanding that thing. And one thing that is just awesome about this is the more times you retrieve a particular idea or concept, or even some procedural memory, like how to drive a car, when you retrieve that, the next time you retrieve it, the forgetting curve levels off a bit. So if you see this initial one drops quite dramatically, but the second one, from day 1 to day 7, so six total days, it's only to 60%. So from the first learned, if we didn't recall again, it would be 3 days, but the second time we recalled it, it is 6 days from that one. So we pretty much doubled our ability to remember just by having one recall on that particular thing. And this trend continues until after you retrieve it and retrieve it and retrieve it, that it becomes something that is deeply maintained within your mind. And so this idea of retrieval practice is about not avoiding, but confronting this forgetting curve and helping us to learn and understand over the long term. So to pull this from the abstract into the actual, examples of retrieval practice are quizzes. So when people get tested on things, this is called the testing effect. When people get tested on things, they're more likely to remember them, right? And so we can do quizzes, self-tests, flashcards, and there are also applications that help you in this learning. With the previous presentations I've given for the Tech Academy, I always shill Anki because this is the application that I use for flashcards. So what I do in my day-to-day learning for retrieval practice is that I will learn a concept or a thing, and then I will pull that thing and put it into a flashcard, right? So a flashcard is a question typically, and then an answer which answers the question. And so what that does is you have a question and it forces you to retrieve that understanding of your thing, of that thing. And then you're able to get really timely feedback onto whether or not you were able to get that concept or you were able to recall it correctly. So Anki is really good. Super Memo, I haven't used that one, but I've heard it's also good. And then I'm also writing an application that sort of addresses, it's called Gwen. I haven't published anything yet. Maybe the next time I do a Tech Academy presentation, I'll have that up and running. But the Gwen sort of addresses some of the shortcomings with Anki, as well as mostly provides additional functionality that helps with structuring your learning as a self-led learner. So retrieval practice is a really important thing. So we'll go to this next one here. So this next concept is called interleaving. And this is the process of alternating between different topics or types of problems within a study session, rather than just focusing on one entire thing for the span of the session. So an example of this in the psychological literature, at least in my mind, the main study that describes this is one where students are practicing math problems, and you have the control group that practices the math problems, and when they practice the math problems, they practice problems of the same type. So say we're trying to find, the slope of a line, and so they will probably continually practice slope of the line problems, and they do that particular thing. The alternate approach, or the test condition in this case, would be that maybe there are 10 concepts that you need to understand, or 10 things you need to be able to do within this this math test. And instead of practicing on them one type of problem at a time, what they did is they interleaved the problems. So when someone was presented with a problem, they had to figure out which strategy they needed to use in order to solve the problem, instead of being like, oh, well, I did the problem this way. The next problem, I will just have to implement the same strategy I learned in the previous problem. So what this does is it builds your ability to not only solve problems, but also to be able to understand what approach you need to solve the problem. So the ability of identifying the correct strategy in a given context is beneficial here. So one thing about this, this one is fairly difficult. Well, it's pretty difficult to implement in just regular programming. There are situations where you can be like, oh, I'd like to do this thing, right? The one area where this is really important, and I guess you can still implement this concept within your programming. Say if you wanted to solve a particular problem, you're practicing different approaches to solving that problem, maybe. I think also if you're wanting to learn multiple programming languages, then you could interleave their use. So if you're solving problems of a particular type, you use different programming languages, and then you're using like different paradigms to solve that problem. So if you do, let's see. So I don't know if you guys have heard of LeetCode. This is a site. Let's get this out of here. Let's see. Can we? Do I have a? Okay, I do not. Anyway, so for technical interviews for programming jobs, typically there are a couple of paradigms for how they, how they go about conducting these interviews. One of them is, I guess we'll talk about three. One, they could have just a technical conversation with you where they're asking questions to you about the various technologies they use and testing your knowledge to see if you are a competent engineer or whatever. Additionally, they could give you a little take-home project where it's like, okay, I want you to build the classic to-do app in the technology stack that we use, and then after that, you'll submit to us, we'll review it, and then we'll decide or maybe have another interview after that. The last approach is like programming problems. So these are typically like data structure and algorithm problems. And so interleaving could be used in this context for learning data structure and algorithm problems. So this could be, you're trying to learn, let's see if I can remember, like dynamic programming. That's a subcategory of programming problems. Another subcategory is like interacting with strings and arrays. So one approach could be to, okay, I'm going to look at the strings and arrays, and actually I have this one I'll be able to show it. Oh darn it, I have to authenticate. Okay, never mind. Actually I think that was the wrong site. Anyway, so one approach could be that I take a particular programming problem, like dynamic programming, and I go through and I complete all of those things for that programming problem. So I go through all of the ones that are on arrays. I go through all the dynamic programming problems. I go through all the 2D dynamic programming problems. So I could do all these things, right? And so the idea is that instead of doing a block on one particular concept or idea, I will start on one, and then I go to a different topic, and then I go to a different topic. And the important part isn't that, well, I guess an important part of this is that in solving the problem, it'd be best to not know which problem is that you need to solve, right? Because you're trying to train not only your ability to solve the problem, but you're also trying to train your ability to pick the right strategy for solving that problem. Okay, and so the last one we'll kind of talk about before we go into Q&A will be changing learning contexts. So this is akin to the interleaving, or rather, probably interleaving is an example of changing learning contexts. But this principle can be applied more broadly. So with this, let's see, I guess there are two approaches, and I'll just talk about one. Is that when I'm practicing a particular thing, I'd like to vary the contexts that I practice that particular thing, because that forces me to be able to have general ability for doing that thing. Okay, so I'll make this more clear. An example of this would be, okay, say I want to learn about a particular technology, like I'd like to learn about what middleware is, okay, or I'd like to learn about what logging is. So an approach I could do if I wanted to learn about middleware, I could go into the .NET, C# stack, and I could learn a lot about like what middleware is, how they implement middleware, and my understanding of middleware would be necessarily tied to my understanding of C# and .NET, right? And so an example of varying this learning context is that I could then go and say, okay, I'd like to learn middleware, but I'd like to learn it in the context of using Node.js and Express, which is another technology stack, right? And so once I do that, I vary my context in learning this concept of middleware. I have my understanding of middleware isn't tied to a particular technology. I understand middleware as a more abstract thing, of which there are two implementations that I understand, which is .NET and C#, as well as Node.js. And that's an example for me that that's occurred recently as I've been working on that application I was telling you about for spaced repetition and sort of like a task management / learning management for self-led learners. I've been doing Node.js, SQLite, and React, and I guess TypeScript as well. But the concepts that I learn at work, because I've only ever done like a .NET C# stack, the concepts that I learn are like similar concepts, right? But I'm learning them in a different context. So it's enriched my understanding of programming concepts because I am practicing those concepts in two different areas or two different contexts. So this practicing increases your generalizability for the particular skill set you have. Yeah, and so I guess I'll kind of wrap up, and then we'll give a little bit of a Q&A. So I hope from this presentation so far, you've learned some ideas or taken away some things that you can do to improve your learning experience. I know these are like sort of abstract concepts when I've been talking about them. Hopefully, as I've talked about like ways you can apply them, hopefully you've been able to grab on and say, oh, okay, with the current learning practice I do, I should probably implement this thing, right? And so, yeah, I really hope that you're able to gather some value from this and that it helps you along in your learning journey. So yeah, thanks for coming. I guess we'll open up to the Q&A if you guys have any like verbal questions, or you can also type them in the chat as well. And then if you guys have any questions about what I do, or like any questions like, oh, what was the interview process like, or yeah, whatever's good.
No, that's a great talk, McKay, and a real deep dive into the science of learning, and really good techniques and some really good advice for learning. I'm curious, how much of these techniques did you know when you started like college or when you started the tech academy?
Mm-hmm. Yeah, that's a great question. So during my undergraduate degree in psychology, the funny thing is we learn about these techniques, but it's like learn about them in a sort of dispassionate view, and not like, okay, let's implement these ideas now. So actually in college, I implemented it somewhat, but I could have gone way harder on doing that or implementing like the techniques. Like an example, one of them that I implemented was a retrieval technique where I would have all the concepts that I needed to learn or to understand, and then I would go through each of those concepts and see if I deeply understood it. And then if I understood it well, I would mark it. I would color. So this was done in Excel. I would color it green, and if I didn't understand it well, then I would color it red. And then I would track every time I review it. I would have a new column, and that would be a new date. And then I would track, oh, am I green, red, or yellow for my understanding of the thing. And that enabled me to look at like, oh, chapter 2 of what I'm learning, and figure out, okay, what things do I understand and what things do I need to focus on for this upcoming test. So I implemented there, but I could have implemented much harder, and that would have shrunk the amount of time I studied like pretty dramatically, because that would have been way more effective. But in the Tech Academy, is actually when I started using Anki, which is the tool I use now for spaced repetition. And so that's been like really beneficial and helpful for me. And then I also use it. So I talked about just a little bit that I've done some additional education. I got a degree from WGU in cloud computing. And in that, I went really hard on all these learning techniques, especially, or I guess not really hard, I guess specifically I focused a lot on spaced retrieval and using Anki. And because of that, I was able to complete like a 4-year degree in 9 months. And so it was, obviously I had like 30, I think I had like 35 credits that transferred over of like the 120 required for a degree, but still I was able to get like, it was like 88 or maybe 78 credits in 9 months. And so, yeah, like these techniques really work.
Yeah, no, that is amazing. And when is your book coming out?
So I'm writing an app, but I
Nice.
think it would be cool to put a book together. Maybe I'll write a blog post on it. So right now I have like one more area that I need to write for the application, and then I will be my goal is to release it in like a month and a half. That's like my hopeful goal. We'll see how that goes, but yeah.
No, that's cool. Keep me updated on that. I
Yeah,
definitely
yeah.
would like to check it out.
Yeah, for sure. Yeah, I'll send it out, and I think now that you say that, I think I'll write up maybe a blog post or an essay on like the learning strategies I use, because I think that would be helpful. Because I mean, the things I use have been refined over
Yeah.
my entire schooling and career. So yeah, looks
Well,
like.
it's easy
Oh, go ahead.
easy to publish a book on Amazon too, if
Yeah,
you wanted
that's
to
true.
do that.
That's true.
So yeah, we do have it's a question from Joy.
Okay.
And the question is, any advice on strategies for staying motivated when everything seems to be failing?
Mm-hmm. Yeah, that's a good question. Things can be difficult when you're like really putting a lot of effort towards something, and you don't see much, I guess, reward for the effort you've been putting in. I think for me, so there's another concept in psychology. It's called cognitive reframing. So this is the idea that you're trying to deliberately change your perspective on a situation. And so an example of this would be like, okay, say I'm in a situation where, I've had a job interview, or I guess I've had maybe 10 job interviews, and I've failed every single one of them. Actually, and I think about they talk about this idea of cognitive reframing in the end of the boot camp, but I've like failed every one of them. Say that I'm in that case. I could say, oh, like, I'm trying to learn, I'm trying to stretch, I'm trying to become an engineer. Like how could this be that I'm like unable to do it even to this regard, so you could view that in a negative light and say like, oh, maybe I'm just not cut out for this, or insert generic negative negative concept or idea. Another approach you could say is that, okay, I failed these 10 interviews. That means that I have like 10 more interviews of practice and under my belt than I had before these experiences. And hopefully from each of those experiences, you're saying, oh, okay, like I'm gaining competency and ability in this particular area. Maybe for each of the ones I have some takeaways, like, okay, I did do this well, I need to study this area more. And so I think reframing would be good. Or I guess that's the approach I'd take. So if you feel like things are failing or things are not going well, then that helps you. And failing is actually a really important step on the course of learning. One of the things I was reading or / like actually it was a YouTube video I was watching in preparation for giving this talk was about deliberate practice, and how one of the approaches towards deliberate practice is ensure that you're failing more often. Because if you're failing more often, it means that there is something to be learned such that you could have success, right? So if I fail in shooting a basket, I could refine my technique and realize, okay, the thing I did not work, right? And environments where you fail a lot are actually I guess you learn more from environments where you fail a lot rather than environments that you just like are able to perform easily in. Hopefully that answered your question. Yeah.
Yeah, failing can definitely be the best learning you can get.
Mm-hmm.
If you really analyze what the failure was, and then you refine it and you're able to overcome it. So, and you can kind of tie that in like with imposter syndrome. Do you have some advice for getting over some imposter syndrome?
Okay. Yeah, that's a great question. So imposter syndrome. So this is like the idea that like I don't feel good enough, that I'm some sort of imposter, I'm like faking it, whereas everyone else is competent and are able to perform well. I think there are at least two good things to learn from imposter syndrome. Is that In one regard, like when you go into a particular discipline or field, like you are some sort of imposter at the outset, right? You like right after I graduated the boot camp, there was a lot of difference between me and someone who's worked as an engineer for 5 years, right? And so in one regard, you are like you don't have competency enough to like say I'm like a pro engineer or something like that, you know. But I think the big thing about the imposter syndrome is that it's saying that like, oh, I need to grow in competency, and that's a great like some people say, oh, you should feel great about yourself, like everything should be like you should feel awesome, all this stuff. I think that feeling incompetent in a particular area is totally fine because it forces you or gives you motivation to grow in your competency. I think the danger for imposter syndrome is that some people feel like an imposter and then don't give themselves a chance. And that's the big danger. If you say, I feel like I'm an imposter, and it forces you to like wait for 3 months to study more before you like begin applying, like you should not do that. Like you should begin applying, because the reality is even people who go to, you know, get a bachelor's degree in computer science, like they really mostly understand theory. Like they've had some experiences with developing, but like they're also imposters. Like when you go in, like you're entry level, like it is what it is. And so yeah, I'd say that in one regard, it's like having the feeling of being an imposter is good because it's you and obviously there's some variation in this, but typically it's, you know, a reasonable feeling given your level of competency. And that just means I just need to have more experience and keep developing. And having experiences, a part of having experiences is having a job. So don't allow imposter syndrome to make you not get to your first position. That's the big idea for me.
Yeah, no, that's really good points. And I think I'd add to that, you know, whether you're getting a CS degree or attending a boot camp, most people feel the imposter syndrome. Almost everybody does.
Mm-hmm.
And you just got to push through it and know that you are going to learn it, and you know more than you think you know.
Mm-hmm.
That's what I find in most cases. All right, so we've got a question from Dan Bryan. It says, what was your experience after graduating the Tech Academy to finding a job? An example, what was your approach to finding a job, and what was your interview process like?
Mm-hmm. Yeah, great question. So for me, I graduated the boot camp, I think in April of 2022. And then I just applied to tons of places. I looked for places that were in the area because I would probably have, or because it was in the area, I was only, you know, competing with those that were in the area rather than going for a remote job that was everywhere. Though I just applied to like tons of positions every day. I think I applied to, for my job, I think I applied to 50 or 60 positions and then had 2 interactions from those. One of them, I had a call with the initial person, was given a technical assessment, and I failed the technical assessment. And then the funny thing about that, for the technical assessment, I felt much more confident in C# than I did JavaScript at the end of the bootcamp, because you interact with C# right at the end of the bootcamp, right? Whereas JavaScript, you do some at the end, but mostly at the beginning when you do JavaScript. But I failed the C# portion and succeeded on the JavaScript portion, so I thought that was funny. my perceived competency, and you know, given like it is what it is, but yeah, I thought it was funny that like the thing I was really worried about, I did great on, but the thing I was like, oh, I got this, I like did not perform well. Anyway, so had that initial one, and then second one, I had an interview with HR, and it was like super easy because like, I mean, HR interviews are just like a behavioral interview. So we talked about some tech stuff, but mostly she was asking me tech questions and then recording my answer because she didn't understand what she was asking pretty much. And she even said that, like, I'm not saying like she didn't understand, but and then so I had that interview. I had an interview with the senior software engineering manager, after which I received a technical project. That project was one where I had to consume an API, and then I had to store it in a database, and then I had to present what was stored in the database to the user. And so I was pretty stressed out when I was doing it. I remember like spending just hours and hours and hours. on that, but I eventually was able to get it. So that was awesome. And then after I submitted my technical assessment, I had another technical interview with the software engineering manager, as well as a senior software engineer on the team. And then they just asked me some more questions about the tech. And after that, I was called maybe 2 hours later and received an offer.
No, good stuff. And yeah, it's there, like McKay said, when he went into the interview, he failed the C#. But that was, you still got the job with that, correct, McKay?
So that was a different interview experience. The
Okay.
first one, I failed the C#, and they said, "Oh, we won't be moving forward." With the second one, I was able to I didn't have like a technical assessment. I was just at a project.
Got it. And now you're a C# master.
Yeah, I guess so.
There you go. All right, we've got a question from Joy. She asked, how do you balance pushing yourself while avoiding burnout?
Yeah, that's a good question. I think for me, what's helped the most is sort of limit testing myself. It is the case that if you are trying to work really hard and push yourself, you will get like a little burnt out. And you will probably have days where you're just not feeling it. In this situation, I think there is a balance, right? You're wanting to be able to increase your capacity to, code and to learn and to do whatever you're wanting to do. But at the same time, you want to ensure that you're not like wrecking yourself, or that you have to take a week off because you've just done this thing to yourself, right? And so I think that for me, viewing working hard or working for extended periods of time as a skill, and then also pushing myself and trying to like set stretch goals. So this would mean recording how much you're working, and trying to increase that metric either in like depth of focus when you're working, or like the amount of time in total that you're working. So see it as a goal and realize, okay, like at my present capability, I can grow from here. I'm not going to be stuck in my level of ability forever, right? And so, viewing it as a skill, and then realize that when you are pushing yourself and limit testing, you will feel like tinges of burnout. You want to avoid like completely wrecking yourself. So this maybe develops with time, and or this self-knowledge sort of develops with time about how hard you should push. So viewing it as a skill, and then just incrementally, like, how do you say for lifting weights? Progressive overload. So slowly increasing. Hopefully that answers your question.
Yeah, good points there. And I think kind of like with retention that you spoke about and how it drops, when you don't continue with your learning and continue practicing. I think that's a big thing. And I try to, really pass it on to the students to code for an hour a day. So, when you finish the boot camp and you're going off, you're looking for work, still code for an hour a day so you can retain the skills and you can build on the skills. And I think that's a real key point for, retention and retaining it.
Yeah, I agree. I think to add to that point, like realizing that you're in the long game for this, if you study for 80 hours one week and then you can't study for the rest of the month because you're so pooped, then yeah, you studied for that long. Maybe you learned a lot of stuff, but the important thing about, the experience you guys are in, whether you attended boot camp, whether you were in a computer science degree, like whatever your situation is, that if you have a particular long-term goal, you are in it for the long game. So you want to maximize performance on the short term, but also ensure that your crazy, effort and things that you do don't damage yourself like later, right? Or don't make it so you have to take like a break from programming, And so I guess there's that balance as well.
Oh, good stuff. And have you read any Malcolm Gladwell?
I did, yeah. Let's see.
10,000 hour rule.
Yeah.
Outliers. Yeah. That's 10,000 hours to master something. So just keep that in mind. Like you're going through, you're learning your code now, learning new concepts. When you graduate, you're not going to be a master. That's going to happen over time. And I'm sure McKay can vouch for that.
Absolutely.
But Malcolm Gladwell, he's an author, wrote The Outliers, got some really good points in his book about what it takes to master something. And on the average, it takes about 10,000 hours to master, be it coding, be it writing, whatever job it is that you're doing. It takes 10,000 hours, but you just got to do it every day. Just keep working towards it, and you will master it. All right, cool stuff. Gab, are you here?
Yes, I am.
Okay. Did you want to add something to the talk?
Just some announcements about our future events.
Okay, go ahead.
All right, so thank you, McKay. This was definitely a learning experience for me. I took a lot of points from you. Definitely gonna apply them personally. Okay, so for our attendees, we have another tech talk next week. So that's Friday again, 1 p.m. Pacific, and we also have other programs available for the students and graduates of the Tech Academy. So we have the Accelerator program, and all of the graduates and students of the Tech Academy are entitled to a 3 months of free access. So we have live classes every Tuesday and hundreds of materials and videos that you can use to review, to accelerate your skill. Hence, that's why it's called Accelerator. And we're also planning other alumni events. Just watch out for some emails in your inbox about the announcements for it. All right.
All right, thanks, Gab. And McKay, I want to thank you very much for coming out for the talk. It was very informative, very well done, very well spoken. I could see your teaching assistant skills coming out with your presentation. So great job with that. We would love to have you back soon. And
Yeah, absolutely.
thanks again for coming out. That was really good.
Yeah, for sure.
All right, all. That's the end of the talk. Thanks for coming out and have a great weekend. We'll see you later.